Today, I will be discussing to you how to express a number in its juxtapositional notation. Okay. So a number stated by, for example, you have 1, 2, 3, 4, 5.6789 base 10 is represented by a certain numbers which is the radix and the weights of each digit's location. So, so bilang lang tayo ng how many digits ang inyong integer part. So 1, 2, 3, 4, 5. So this is stated as A4, A3, A2, A1, A0. Point. This is A negative 1, A negative 2, A negative 3, and A negative 4. Okay, so to express your numbers in juxtapositional position, so you can write this one as 1 times 10. So this is times 10 because it is on decimal notation. This is base 10 times 10 to the 4 plus 2 times 10 to the 3, and then plus, that is what's next is 3 and exponent 2. Then we have 4, then exponent 1. And then we have plus 5 times 10 to the 0. And then you just add after the radix point. So this is 6 times 10 to the negative 1 plus 6. Sorry, that is 7 times 10 to the negative 2 plus 8 times 10 to the negative 3, and then plus 9 times 10 to the negative 4. Okay, so that is the juxtaposition notation of this number base 10. Okay, for example, you have a binary, this time a binary number. So, example, that is 1101. Okay, so you need to find its or to express that in juxtapositional notation. Okay, so that is the same. This is, so how many digits or integers are there in the digits? So you have 4. So this is 4 digits. So this can be expressed as A sub 3, A sub 2, A sub 1, and A sub 0. So be sure to start at ones place at A sub 0. Or any numbers that before the radix point should be expressed as A sub 0, and the maximum should be n minus 1, or the number of digits minus 1. Okay, so this is 4 digits, so the maximum is 3. So n minus 1. So to express that, we know that this binary number is base 2. So we can express that as 1 times 10 to the 3 plus, that is 1 times 10 to the 2 plus 0 times 10 to the 1. And then next is, oh sorry, that should be not times 10 because we are talking about base 2. So we will write as 1 times 2 to the 3 plus 1 times 10. Sorry, that is 1 times 2 to the 2. And then we have plus 0 times 2 raised to 1. And then we have plus 1 times 2 to the 0. So that is its juxtapositional notation. So we could uh, sum up this one. This is your answer for the juxtapositional position. But if you want to find the decimal, your juxtapositional notation always yields to an answer of decimal base or base 10. Base 10. Let's say it's base 10. Okay, so let's try to add up. This is 2 times 3 is 8 times 1. This is 8. 8 plus 2 times 4. This is 4. Plus this one becomes 0. And this one becomes 1. So this becomes 8, 12, 13. So that is 13. So this is the decimal or the base 10 equivalent of this binary number. But the juxtapositional notation should be this one. Okay. Okay, so that is the proper way to express any numbers of any bases to a juxtapositional notation. So try to check if 110 is corresponds to your 13. Okay.